This is the Calculus 1 lecture for section 4.2. And this is an introduction to the definite, what we refer to as the definite integral. Calculus 1 is oftentimes referred to as differential calculus because we spend a lot of time finding derivatives. Like most of the semester, we spend on derivatives, differentiating. And so Calculus 1 is referred to as differential calculus oftentimes. Whereas calculus 2 is oftentimes referred to as integral calculus. So notice the integral is underlined. And in calculus 2, you spend a lot of time on what we refer to as integrals. And you spend a lot of time integrating, which we'll talk more about later. But right now, section 4.2 is an introduction to what we call the definite integral. In order to get us ready to study integral calculus. So this symbol that I just wrote here, you might notice that there's this elongated S right there. That symbol, when we see it in mathematics, we read it as an integral. And this entire expression that I wrote, you're going to read it like this. So when you see this, you're going to read this as the definite integral from A to B of f of x dx. Like that's how you'll read that. The definite integral from A to B of f of x dx. And generally, what this definite integral represents is like if you have let's say you have a curve. Here's a curve. And I'll let it keep going. And let's say that this is A and here we have B. In general, what that definite integral from A to B of f of x, by the way, this curve is y equals f of x. In general, what that definite integral represents is the area under this curve here. So the shaded region, the area of this shaded region right here. So this definite integral from A to B of f of x dx, that's the area of the shaded region. That's what that represents. You can think of the definite integral as being the area under a curve. So, but that's only if your curve is above the x-axis. So let me just say the definite integral from A to B of f of x dx is the area under the curve if the curve is above the x-axis. If the curve is below the x-axis, then it represents something else. So I'll just, so this description, it matches this picture right here. Right? So we think of that definite integral as representing the area under the curve when the curve is above the x-axis, which is what we have in the picture. Here's another picture though. Let's suppose that we have a curve that is below the x-axis. So let's say we have a curve like this, right? And here's our A, and here's our B. And here's the shaded region. So in a case like this, the definite integral from A to B, and again, let's suppose that this is our f of x. So of f of x dx, it's still going to be the area of that shaded region right there, but it ends up actually being the opposite of the area. So it actually ends up being a negative number. So it's negative the area of the shaded region. So in other words, negative the area above the curve. When the curve is below the x-axis. Now, the reason for this will hopefully make sense at some point next week, or maybe the week after. But for now, I want you to think of like just this initial idea of you having this curve above the x-axis. And when that happens, the definite integral represents the area underneath that curve. From x equals a to x equals b. And if your curve ends up, it happens to be below the x-axis, definite integral still represents that area between the curve and the x-axis, but it ends up being a negative number for reasons, again, that will hopefully make sense next week. So right now, let's look at a homework problem. So this is section 4.2. Let's look at problem number 1. Oops, number 1. Wait, what? What did I do? Why can I not? Oh, well, I guess I'll just look at it like this. So problem number 1, it's asking us to evaluate the integral below by interpreting it in terms of areas. They ask us to draw a picture of the region. Don't draw a picture, just use Desmos. The main thing I want you to use this homework for is to understand this, like what this is asking you, like what it means, what it represents. So if I go to, I'm just gonna go to Desmos graphing calculator. Let's see. And I'm going to next, where are we? Here we are. Enter the square root of 7 squared minus x squared. That's a half circle. Square root of 7 squared minus x squared. I'm struggling with my new laptop to like find everything. So this is a half circle. Notice -7 is where it starts, and then +7 is where it ends. And when it's asking us to find that definite integral from, like, notice it says definite integral from -7 to +7. So here we have from -7 to +7. It's asking us to find the area underneath that half circle. That's what this is asking us to find. And so I just want to know that you understand that that's what this is asking us to find. And then go ahead and find the area. So we're trying to find the area that I'm shading, that I'm trying to shade in right now. It's taking me a while. It's going to take me a while, but not too long. It's not that bad, right? But I'm trying to find the area, this area that I'm shading. And since I know that this is a half circle, I can use the formula that we have for the area of a circle. Area equals pi r squared. So we're going to use that formula. In order to use that formula, I need to know what my r is, my radius. And notice that for this half circle, the radius is 7, right? The radius is it's the distance from the center of the circle to like any point on the circle. And notice that that's 7. And and so I'll just go to my iPad at this point. I'll write the problem down and go to my iPad. All right, so I wrote the problem down. I just want to emphasize that this was a half circle. And so this is asking us to find the area of that half circle. And we know the formula for the area of a circle is pi r squared. And we know that our r in this case was 7. And so for us, we will have half of pi times our r squared, 1/2 pi times 7 squared, or in other words, 49 pi over 2. This is our answer. That's it. So it's really like you interpreting this definite integral as the area under that curve. That's what these problems are about. So where is so here I'll just enter 49 pi over 2. And there we are. So let's look at problem number 2. This one's asking us to evaluate this definite integral from 0 to 7 of the absolute value of 6x minus 9 dx. So I'm going to go to my Desmos and let's enter this function y equals the absolute value of, what was it? 6x minus 9. 6x minus 9. And we were finding the definite integral from 0 to 7. So you want to pay attention to these numbers here. The 0 and the 7. So that means we start at 0 and we end at 7. Like that's the kind of the interval that we're looking at. So we start here at 0 and then we're going to end over here at 7. So let me mark this 7 so we know where that is. Let's make the steps 1 so we see the 7. Right. One other thing I'm gonna do, because so if I plug in 7 for x, I get 6 times 7 is 42. 42 minus 9 is 33. So I think what I'm gonna do is I'm gonna I know my y values I have to are gonna go way up to 33 for what we're looking at. So I'm gonna change my y's here. Let's make it, yeah, we can keep that the same, but let's make this go all the way up to 35. Yeah, yeah, that looks good. That looks good. So now I think we can see everything, right? So let me get rid of this, and we are going from 0. So like starting here, and then we're ending at 7. So again, those numbers 0 and 7 I got from the original problem. Right, so going back to the original problem, 0 to 7. So I start at 0 and I end at 7. So, which means my job right now is to find the area under here. So basically the area of this smaller triangle here. And then the area of this big triangle here that I'm shading here. Shade like this, just to shade it a different way. So I'm finding this area. Here, I'm gonna pause this while I do this. Okay, so I want the area of the smaller triangle plus the area of the bigger triangle. Area of smaller triangle plus area of bigger triangle. That is my job. I need to find those two areas, right? And I'm going to make use of Desmos and make good use of Desmos because first of all, I know that to find the area of a triangle, I know the formula is 1/2 base times height. Oh my goodness. I struggle. 1/2 base times height. So I need the base of my triangle and I need the height of each triangle. So and that's what I'm going to use Desmos for. So I don't have to work that hard to find the base and the height. So like, sorry, the smaller triangle, I'm just noticing this point right here is 1.5. Now you could figure out that point yourself by taking 6x minus 9, setting it equal to 0 and solving for x. But I am using this shortcut way. I'm just using Desmos. And the base of my smaller triangle I see is 1.5. So I can just say that this base is 1.5. Oh, that's so, I don't want to move. If I move this, then my shading is going to go. But hopefully you can see. The base of my smaller triangle is 1.5. And then the height of my smaller triangle, again, you can figure out what that is by plugging in 0 for x and getting a 9. But you can also just use Desmos and you see the height is 9. So for my smaller triangle, I get to write smaller. Oh my goodness. I am getting used to this keyboard. Triangle, my smaller triangle area is 1/2. My base again was 1.5 and my height is 9. So 1/2 base times my height, 1.5 times 9. And then let's get the bigger triangles area. That'll be 1/2. And the base of my bigger triangle, that's going to take some extra work. This one I can't just rely on Desmos for because I know that, so I have 1.5 here, but then I go to 7. So I have to do 7 minus 1.5, which ends up being 5.5, right? But I'm just going to put here just to make it clear where I get that 5.5 It's 7 minus the 1.5. That's my base. And then my height, I can get by plugging in 7 for x. 6 times 7 is 42. 42 minus 9 is 33. Or I can go to Desmos and be like, okay, what's this point? That's 7. Oof. 7. There we are, 33. You see? So my height is 33. My height of my bigger triangle is 33. So this will be times 33. And then I just need to add these, all these, like these two numbers up. So 1/2 1.5 times 9 plus 1/2 7 minus 1.5 times 33. I'm going to enter this in the calculator. Go to the calculator. So I have 1/2 times 1.5 times 9 plus, I can't tell if I'm entering this correctly, but hopefully I am. 1/2 times 7 minus 1.5 times 33. I got 97.5. Let's see if that's correct. $97.5. Yay, it's correct. It's correct. Let's look at another one. So hopefully you get the idea with these types. Question 3, go to Desmos, put this in there, and then look at it from 2 to 9. Let's see what's going on. Oh, you know what? Actually, number 3, let's look at this one because I just noticed something. If you plug in 2 for x, notice you end up with a negative number. 2 times 2 is 4, and 4 minus 8 is -4. So here's one of the ones where you have a negative. So let's look at that. What was the function again? 2x minus 8. And this was going, so the numbers I want to pay attention to are the numbers I want to like start from. The number I want to start from is 2. Oh, come on. 2. I want to circle you. I'm trying to circle 2. Let me circle. Why am I struggling so much? Why? Okay, so I start at 2 and I'm going to end at 9. So I'll go to my graph. I will start at 2 and end at 9. Let me change my my x's and my y's. For x, let's go from 0 to 10, or maybe 0 to 12. And then no, for x, let's go from like -2 or -2 to 12. Just give me some more to work with. Oh wait, no, we'll start at 0, sorry. And then for y, let's go from negative 6 to 2 times 9 is 18. 18 minus 8 is 10. So let's just go from here to there. Okay. So much work. But I feel good. I feel good. So if we're being told to start at 2 and end this at 9, we are going from here to here, starting at 2, ending at 9. And here's the thing. We have two triangles once again, but notice the first triangle is actually below the x-axis. So what that means is when I find my area of this thing, I'm going to stick a minus in front of it. That's what that means. And then I also need to find the area of the bigger triangle. So once again, I'm finding the area of the smaller triangle. But when I find that area, I'm going to have to stick a negative in front of it. But let's just first find the area of the smaller triangle. So just looking at this, it looks like the base of the smaller triangle is 1, 2. It goes from 2 to 4. So it looks like the base is 2, right? And then the height of the smaller triangle, it goes up to -4, or goes down to -4, I should say. So the height is 4. And so my area will be of this triangle, the smaller one, it's 1/2 base times my height. And that ends up just being 4 in this case. And because it is below the x-axis, we'll put a minus in front of the area. So we're going to end up like entering this as -4 when we combine it with the area of the bigger triangle. So now let's look at the area of the bigger triangle. So we'll have 1/2 again. And then the base of the bigger triangle, it looks like is what? We start at 4 and we go to 9. So that looks like the base is 5. And then the height, 2 times 9 is 18. 18 minus 8 is 10. So it looks like the height is 10. I got that by plugging 9 in for x, but you can also use Desmos, right? You can go to Desmos and be like, okay, what is this point? What's the y value when x is 9? The y value is 10. So you can also do that. Use Desmos. So, but we have our base, we have our height now. So we know that our area of the bigger triangle is going to be 1/2 5 times 10, which is 25. Is that 25? I think that's 25. That's what I think. I think. And so you're going to add these areas, the -4 plus 25, that gives us 21. So that's what our definite integral ends up being equal to, a positive 21. So yeah, I'm glad we looked at that one. I was going to skip over this one, and then I was like, we get an example of having part of our curve below the x-axis. So good one to look at. Let's look at a different problem. A different type of, so this basically this section is about finding areas, which is kind of what 4.0 is. It's just that here, like it's using this new notation, the definite integral notation. So problem number 4, like it wants you to like say, okay, what's your A, what's your B? Your A of the for the shaded region here, it looks like your A is 1. So A is always where you start. And then it looks like your B is 4. B is where you end. And so for this problem, my A would be 1, my B would be 4. My function f of x, so to do that, I'm not going to do that here. But your job for your problem, your job will be to find the equation of this line. So you have to find the equation of the line. And it's going to be in this form mx plus b, right? Oh, I guess I can do it. I can find this quickly. It looks like the b is 5, right? Am I right? It looks like the b is 5. I'm going to guess that the b is 5 because b is the y-intercept. And then my slope, it looks like my slope, I go down 1 to the right 1, down 1 to the right 1. Looks like my slope is -1. Okay, so I'm going to guess that if I'm reading this correctly, I'm going to guess that my function is -1x, my slope being -1, plus 5. Oh, that's correct. But my B, it was incorrect. Why did I circle that 4? Oh, I don't know why I circled that 4. So the first part of the problem was incorrect. That should be a 3 because that's where the shaded area ends, right? I have no idea why I circled that 4. So that should be a 3. But look at my line was right. So hopefully maybe your line will be just as nice as mine. And then from here you go ahead and find the area of this shaded region, which is basically finding the area of this trapezoid right here, right? Which was section 4.0. So let's look at another type of problem. Oh my goodness, come on. Just trying to get rid of all my little pictures. Okay. So let's look at number 5. And then I will let you be. So number 5, it says evaluate the integral below by interpreting it in terms of areas. And then the areas, we're given these areas of these labeled regions. So we're told that like A1 has an area of 7, A2 has an area of 4, A3 has an area of 2. So I'm getting these numbers here. And then it says A4 has an area of 2 also. And I think the main thing, and it says we're finding the area from 0 to 7. So I think the main thing they want is to know, first of all, that you're starting at 0 and you're ending at 7. So I can just ignore this over here. I don't have to worry about this because that's after the 7. And then also know that when you have a curve above the x-axis, you're going to write your answer as positive, but when it's below, write it as negative. So we're going to add up these 3 areas, A1 plus A2 plus A3, the A2 being negative though. So we will have 7 minus 4 plus 2, which is 5, right? And that's going to be my answer. It's 5. One other thing before I say goodbye for this section is I want to mention for the very last problem here, down here. I want you to kind of think about this in terms of, so the first part of this problem, part A, it's asking you to, it gives you this function that represents the velocity of an object. And part A is asking you when the velocity is 0. So part A is pretty, it's not using any calculus or anything. It's just asking you to take 26 minus 2t, what they give us is the velocity, find out when this equals 0, solve for t. That's what that part's asking us to do. But then, okay, I couldn't, it looks like it's the answer is going to be 13, right? For part A. But then part B is asking you to kind of deconstruct this formula right here. Rate times time equals distance, right? Rate times time equals distance. Like if I travel, if I drive 60 miles per hour for 3 hours, I will have driven 180 miles, right? 60 times 3, rate times time. So because rate times time equals distance, you can think of distance as an area, like base, or actually think of time as the base, right? And the rate in this case is the velocity. So it's like height times base equals area of a rectangle, right? So when they're asking you how far does the car travel during this time, it's asking you to find the area under this function v of t equals 26 minus 2t. From 0 seconds to 13 seconds, and the 13 I got by solving this equation right here, I got by solving this for t. Like when we solve this for t, we end up with 13. So you're basically finding the area under this function 26 minus 2t from 0 to 13. So you can put this function in 26 minus 2x, and here's 13, right? And so you're finding the area underneath this triangle here from 0 to 13. So that's what you're doing for that problem. I want you to think of it in terms of area, because rate times time in this case is like the rate is the height and the time is the base. So, okay, take care. Bye.